Hey, today we're going to learn how to solve an equation by finding a square root. And that will allow us to solve some specific types of equations in a method that's a little easier than the factoring method we learned before. Unfortunately, we can't do this for all problems, but we'll get into that later. So, first of all, what is a square root? So, up here is the standard definition that you might see in a textbook. Something is the square root of a number if r squared equals n. And I just wanted to give you a handful of examples here. First of all, 4 is a square root of 16. And that's because if you plugged in 4 squared equals 16. So one of the reasons I think it's called a square root, besides the squared part in this equation, is because if you were to take, say, 16 dots or coins or squares or something like that and arrange them, you can form a perfect square with 16. And that square then has 4 on a side. Now you can't do that with all numbers, but you can do it with special numbers like 16 and 25 and 36, which are called perfect squares. So anyway, that's a little bit of the history of why it's called a square root. So there's another square root of 16, which seems a little strange, but negative 4 is also a square root of 16. Now, I can't really draw negative 4 rows or columns, but you can plug in a negative 4 into this formula, and negative 4 times negative 4 does in fact give you 16. So it's kind of interesting. 16 has 2 square roots. You can take the square root of other numbers that aren't perfect squares. Your calculator's been programmed to do that. 29, for instance, it's about 5.38. So, and if you wanted to find that, it's pretty simple. Find on your calculator where the square root key is. I'll show you on a TI-83 or TI-84, they put the square root key above the squared. And so in order to find the square root of 29, you have to hit second square root and then your number, 29. I like to close it with parentheses. You actually don't need to, but 5.385 and all that sort of stuff is the square root of 29. And yeah, that's how it works. So anyhow, a couple more things about square roots, and then we'll see how we can use them to solve equations. First of all, as we saw earlier, positive numbers actually have 2 square roots. So 16 had both 4 and negative 4. And just a little bit, if you see the square root symbol written down somewhere, that usually means the positive version, the positive number. So we usually talk about 4 more often than not. But if you need to emphasize the positive root of something, you might see something like that, plus square root. Or if we really need the negative root and we want to refer to the negative root, we'll put a little minus sign in front of it. And quite often when we are talking about both roots, you'll see in front of the square root symbol the plus or minus symbol. And so that just means both roots. We're talking about them both at the same time. So now, 0 is a unique number. 0 has only 1 square root. The only number that when squared is 0 is 0. And so it does not have positive or negatives. And then negative numbers don't have, or at least they don't have what we call real square roots, because there's no number that I can think of that multiplies up when you square it by itself and becomes negative. Negative numbers times themselves become positive, and positive times positive is positive, and so on. Now, I want to give you a little bit of a hint. We'll study this more in Algebra 2, but mathematicians did invent a number, a system, that does allow you to take the negative square root, and that is the imaginary number I. I is defined just like e or pi. It's a number of sorts, and I is defined to be the square root of negative 1. And it has a whole bunch of really interesting properties, and but anything that has an I in it is called an imaginary number. I don't like that name because it makes you think that they don't exist and they're not real tools that you can work with. It is. It's a really nice tool that helps you answer a lot of questions in electronics, for instance, and many other fields. But anyhow, I is the square root of -1, and so if you wanted to take the square root of -16, if you try to type that on your calculator, it'll give you an error. So if I just typed square root of -16, oops, forgot my one, -16, notice it gives me an error, which is that it's a not real answer. There's no real answer there. If you wanted to, and you can do this when you, especially when you get to Algebra 2, you might want to, if you go to Mode, you can go down to, instead of just allowing real numbers, if you go over to A plus BI, now if I go through the same process, you'll see that it gives me an answer. 4 is the square root of 16, and then the I is involved because you've got a square root of a negative. Now I'm way off topic because this lesson is not designed to be about complex numbers and I and so forth, but anyway, just a little preview of what's to come. Now, how do we use this square root to solve problems? So, first of all, if you have any equations that have x squared in them but don't have x, then you can use this method. Otherwise, you can't use this method because you're not going to be able to get rid of the x. Then you kind of have to factor. So, but if you got an equation like this, 8x squared plus 10 equals 42 or something, there's no x term anywhere, then you can try this technique. And it's pretty simple. In fact, it's pretty intuitive. You try to get x squared alone, just like you used to try to get x alone. So do steps, try to get the x squared by itself. Once you've done that, then you take the square root of both sides. And I put this third step in here to write your answers appropriately because there's a couple scenarios that can come up. First of all, if you end up with x squared equals a positive number, then remember you have two answers because there's two different roots, the positive root and the negative root. If you end up with x squared equals 0, that's kind of an easy one. Then there's only one answer, and that's 0 because it's the only 0 is the only root of 0. So the third case that might come up is x squared equals a negative number, and if that shows up, there aren't any real answers. And in Algebra 1, we usually just write that, no real answers. But then when you get to Algebra 2, you'll have to write in some sort of an expression that has i's involved. So here's a bunch of examples, and then that's it. That's what we got today. So x squared equals 4. This is already x squared by itself, and so I'll go straight to the take the square root of both sides step. The square root of x squared is just x. And then this was a positive number, and so there are two possible answers. Of course, the 2 times 2 is 4, but then also negative 2. So you can write it like this, 2 or negative 2, or if you want to save space and look cool, you can write plus or minus 2. Down here, same thing. I've already got x squared by itself. I'll take the square root of both sides, and x equals, and this one didn't work out perfectly. If you'd like, you may write it just as plus and minus square root of 5. Or if you really want to know the number part of it, then get out your calculator and type it in. I believe it's 2 point something. So let's see that here. Oh, I already closed my calculator. So square root of 5 is 2.236. So you can write plus or minus 2.236. Now I will say this, I rounded this number, and so if you write it as an approximation like this, you should use the approximation symbol to indicate to people that. If you just leave it as square root of 5, that's what we call an exact answer, and you can leave the equal sign there. For this one, x squared equals 0. The only way that can be is if x is 0. So when you take the square root of both sides, you get 0. And this one, x squared equals negative 16. If you try to take the square root of negative 16, you can't do that without invoking the imaginary number I. And so in Algebra 1, we just write no real answers. But in Algebra 2, the answer would be plus or minus 4i. I won't mark you down on a test if you write it correctly using Algebra 2 stuff, but I would focus on no real answer instead. That's a little easier. Anyhow, here, x squared plus 10 equals 46. This I do need to do more steps. I got to try to get x squared by itself first, and then I can take the square root. So these 10s should go. We should get over here, so just a subtraction. And we get x squared equals 36. And then we can take the square root of both sides. And we get x equals either plus or minus 6. So, lastly, I should try to get x squared by itself. I'm going to add 40 to both sides first. And we get 3x squared equals 48. And before I take the square root, I should get rid of this multiplier of 3. And so that gives me x squared equals 16. And that's a perfect square. That's 4. 4 squared. So x could equal either 4 or negative 4. So I hope you find finding or solving an equation by finding square roots to be easier than some of the other solving methods we've learned. The downside to the easiness of these is the fact that you can't solve all of equations using it. As soon as there's an x squared term, as soon as there's an x term somewhere, like this, maybe I can add 10 to get stuff on both sides, but now what? Subtracting 5x's, but I don't know how to take the square root of 50 minus 5x. That doesn't clean up nice like it does normally. And so maybe you put the x back over here, maybe you try to factor it, but then you've got x times x plus 5 equals 50, and that's not as nice as if factored form equals 0. And so, yeah, you can't solve everything with this particular tool. But if there isn't an x squared term in there, then this tool is great and a much simpler way of solving it than trying to factor it. So, thanks for watching, and tune back in next time so when we learn about the quadratic formula, which is the answer to solving all of the equations. Now, because it can solve all equations, it's a little harder to use, but hey, at least we'll be able to solve anything that they throw at us. So, have fun, have a good afternoon, see you next time.